The dairy industry has received considerable consumer and legislative attention due to its climate and environmental impacts. Feed additives, such as plant secondary metabolites, which include both tannins and saponins, may be part of the solution to curbing these impacts. Tannins have demonstrated increases in nutrient use efficiency and decreases in methane, whereas saponins have decreased methane emissions through various in vitro experiments. My name is Angelica Carrasco, and my research focuses on assessing a commercially available feed additive known as Silvafeed BX, which includes both tannins and saponins, to see if it does in fact help decrease methane emissions without leading to reductions in productive performance in lactating dairy cows. So for my experiment, I enrolled 20 lactating Holstein dairy cows into a randomized complete block design. My cows were blocked based on days in milk and parity, with 2 cows per block, 1 cow being assigned to control, while the other cow was assigned to the treatment additive, which was comprised of approximately 0.07% of dry matter and added to corn. The cows were individually fed, and the treatment was applied as a top dress at each of the feedings. Enteric emissions were measured via head chambers for a period of 12 hours on the block's respective treatment days, 0, 16, 32, and 48 days on treatment. In addition to this, I also collected refusals to determine dry matter intake, recorded milk yield, and collected samples of milk to determine energy corrected milk, as well as yield for milk fat and milk protein. So what we found was that when including the additive, there was a tendency for reduced methane and carbon dioxide production, significant reductions in nitrous oxide production, and a tendency for increased ammonia production. Gas intensity for each of the 4 gases was unaffected. And for methane, CO2, and nitrous oxide, there was no difference between our control and our treatment with respect to gas yield. With ammonia yield, there was a tendency for an increase. However, it is important to note that there also was a trend towards significance with respect to the interaction between treatment and test date, and so there could be confounding variables with the test date itself. With regard to productive parameters, there was no differences between control and our treatment groups. And so the general conclusion was that when including BX at a rate of 0.07% of dry matter, there could be potential for reduced methane with no negative impacts on production parameters. Thank you very much.